body can be moving from point A to point B, maintaining a particular speed. What am I saying? I want to move from this point to this point. I can decide to be taking step. You understand? It means that I'm moving to that other point, which is respect to what? A constant step. But if I want to move from this point to another step, I started with a step. And before I get to that point, I started running again. It means I've changed my speed. Do you understand? So if I'm on that other option, that is taking a step and eventually started running, then I'm maintaining this particular graph. What do I mean? I'm ascending in terms of my speed. She gets. So at this particular junction, what has taken place here is a very constant speed. I mean, it's not a constant, but what? An increasing speed. And that is what we have seen here. But the other way around, if this particular body, or if I have to be taking just the step, just a continuous step, maintaining the what? Step, you understand? Increase in step thing. I didn't increase it. I'm just trying to maintain it till I get to that particular location. Then that is not this type of graph. Don't worry, we'll get there as we move on. So let's move on to the next thing. Now we'll be looking at position versus time graph, which you have explained. Now let's look at the other phenomena or the other scenario where you have movement of what? A particular body at constant speed. How do you judge the graph for that? Remember, we said movement of a particular body. This is distance in respect to meter. This is time in respect to what? Seconds. If it's increasing this way, it's what? It's experiencing what I call increment of what? Of speed. You understand? If you have this type of a graph with respect to distance and time, it means that what? It is what? It is increasing with respect to what? Speed. But if you have this type of graph, with respect to what? Speed. Let's use this as speed. That's your S in meter per second. If you have this type of graph, speed to time, and you now have something like this. Now, mind you, this is 0. Let's say this is 0, this is 2, this is 3, this is 4. You can see as the speed is increasing, time is increasing. Do you understand? But at this junction now, let's say at 5 meters per second, and you have a straight line. It means that there is no increment in speed. It means that that particular body is moving, but is maintaining a particular speed. So at this junction now, you have what we call your uniform speed, which will be explained the other time. Hope you understand the difference now. The first one spoke about or talks about movement of a particular body. While the body is moving, there is an increment in speed. While the second one talks about movement of a particular body, but at a constant speed. So that's just the difference between the two. So an object moving at a constant speed always creates a position versus time graph that is in a straight line, which is the second analogy that I just been explained. So it's a very straightforward scenario. There is nothing difficult there for you to understand. The first one, while the movement is taking place, there's an increment in speed. While the second one is working with respect to what? A constant speed. Now, reading a graph. Now, a graph can give you an accurate answer even without doing an experiment. You understand? You must be able to what? Read your graph. If, peradventure, you want to write your SSC, JAMB, whatever. Now, whatever graph that is being given to you, you should be able to what? Analyze the graph. I can decide to give you another type of graph now. Okay, I'm not putting speed here. I remove my speed and time. I remove this. And now decide to write. I decide to put acceleration. Acceleration to time. I decide to put another thing called acceleration. Same acceleration to time. If I ask you to, break down this. What does the two graph mean? Or meant? If you look at it that, wow. What's the vertical axis? What is it actually indicating? Talking about acceleration. The what? Horizontal axis is talking about time. Okay, what does the graph mean now? It means that as my acceleration is increasing, my time is increasing. That alone explains the first graph. Now the second graph, if you look at it, this is meter per second squared. If it's acceleration, are we getting it? So it means that as my acceleration is remaining constant. As my time is increasing, you can see the graph, the time is increasing. At this junction, time is 0. Now as it's going this way, the time is increasing, but my what? Acceleration is not increasing. It means that this particular movement, acceleration is constant, but what time is what? Increasing. That explains it. So you should be able to read your graph wherever you find yourself, no irrespective of whatever physical parameters that is being labeled. I mean that it is being labeled. Now let's move on. How do you now predict your graph? How do you read your graph? When I say read your graph, this is it. Okay? Look at an example there. I have an example there that spoke about okay, let me do it this way. You have a graph. Now, here at this junction, we have the speed. It's being labeled in speed. That's meter per second. Now, at this junction, it's being labeled in position or distance, whichever way you want to call it. It's labeled in meter. Are we seeing it? Now, if I'm to label this, if I'm to say, okay, at this junction, I have 10 meter per second in terms of speed. At this junction, I have 20 meter per second. At this junction, I have 30 meter per second. Now, here I have 5, that's 5 meters. Here I have 10 meters. Here I have 15 meters. And here I have my 20 meters. Now, what do? If peradventure there is a graph here, there is a point, let me say a straight line. The straight line is drawn here. 10 to, of course, you know that this is probably 7.5. Do you understand? If you draw this, you bring it down. This could be 12.5. Now, if you try to put this up to and bring it down, this could be 17.5. As you can see, they are straightforward. Now, if someone now decides to tell you to predict, what do I mean by predict? It's come in form of question. Predict what the position will be. This is how the question will be. Predict what the position is when the speed is, let's say, 35 meters per second. Are you seeing it? It's called a graph of prediction. What do you do? What are you expected to do? Mind you have to note it in your mind that you dare not just do your predictions or plotting of your graph on a plain paper. It has to be on your graph book so that your what? Choosing of points will be accurate. Now, immediately that is done, you now come back to the question. How do I predict the position? I was being told to predict position when my speed is this. What am I expected to do? Come down to my 35 meters per second, which is after the 30 here. Check it. This is 15. This is 25. So if this is 30, this should be what? 35. So you are expected to draw this 35 down and then bring it down to whatever it was fixed. You understand? Practically, or let me just approximately, what I picked here was what? 20 meters. So automatically, you just say from my graph, 35 meters per second speed is equivalent to what? 20 meter position. That's all. Are you getting it? So if you are being given such a question, if you are being thrown such a question, what are you expected to do? You must make sure that your graph, number one, this graph plotting or drawing of graph must be done in a what? In an accurate graph. Now, maybe that is being established. You now locate all the points given. That's 2. Now, the third point is, the third thing is, you now go back to the question. If I'm given a particular value with respect to any of the scale, the horizontal scale, the vertical scale, I'm being given a value. Now, what am I supposed to do? How do I locate this? Just draw your line, draw your broken line, and make sure it gets to the what? The diagonal line. You understand that is connecting the initial value, and then bring it down. Whatever value cuts here, that is the particular value for that. So that is all about predictions. Yeah, another thing I would like to introduce under your speed stroke time or speed versus time graph is slope. In your SS2 and SS3 syllabus, you'll be using this slope more frequently. Now, if I want to have a graph of this manner, now if my graph is to be drawn upward this way, now of course this is my y-axis, which could be measured in whatever. Let's just say y-axis, and this is my x-axis. Now, mind you, this word slope could either be negative or what? Or positive. A positive slope can be located when, let's say, when you have your diagonal line. Let me say, when you have a diagonal line of this structure, why a negative slope can be gotten when you have a diagonal line of this structure. Are we getting it? So you have to understand that how do I get the negative slope? I only get the negative slope if my what? If the end to end of my what? Of the diagonal line is actually starting from what? My y-axis. You understand? And ending at the point of my what? X-axis. But a positive slope will give you when your what? When your diagonal line is actually starting from point 0 and extending upward. You understand? Diagonally, then you have a positive slope. But when you have this type of slope, it's a negative slope. Now let's start with the positive slope now. Now how do you calculate your slope? Remember, you must locate 2 points. Rules of what? Generating slope. You know, you have to know all this. These are the rules in generating your what? Your slope. Rule 1. Locate 2 points. You have to locate 2 points. On what? On y-axis. The second point is what? Locate 2 points on what? On x-axis. Now, when that is being done, how do I locate? This is my y1,